Welcome back to the deep dive. When you think about modeling something like a whole country's energy system, the future of it, it's just staggering, isn't it? Millions of data points, demand going up and down, new tech popping up all the time. How does any tool even start to wrangle all that information? From electricity needed every single hour to, say, the exact cost of a new wind turbine. Today, we're going to really get into the energy plan model. It actually handles this complexity quite elegantly. Our mission is to sort of pull back the curtain on its foundations, the libraries, the settings, how it processes and analyzes all this super detailed energy data. We'll unpack how it organizes the inputs, those distributions over time, the costs, and how flexible settings make the analysis so powerful. I think this deep dive might reveal some, surprisingly neat solutions to managing complex data.
Yeah, and it's interesting because understanding this architecture, as you called it, isn't just for tech folks. It's really key for appreciating, the model's power, its reliability, basically, for trusting the answers it gives you. It's neatly organized. You've got the main program file, an executable, and then this data directory. And inside that directory are the three core libraries: data, distributions, and cost. It's really quite structured.
Right. And you mentioned there are also the Energy Plan Help and Energy Plan Tools directories, too, so extra support there as well. Okay, let's unpack this then. Let's start with that first one, the data library. What exactly is stored there? What's its main job?
So the data library, that's basically where the main input data set lives. Think of it as the model's core information bank. And it's built to be really robust. EnergyPlan always makes sure it has enough data to run the calculations. And crucially, if you try to load new data, it checks it. It validates it. If the new data doesn't meet the internal standards, it just rejects it.
So it stops you from putting bad data in.
Exactly. It's not just a helpful feature. It's fundamental for trusting the model. Avoids that whole garbage in, garbage out situation you sometimes get with complex models.
That validation sounds absolutely critical for trust. And I heard about a start data feature. How does that work? Does it help people get going?
Oh, yeah, that's a really smart starting point. When you first fire up EnergyPlan, it automatically loads a default set of input data called start data. So you get a complete working baseline right away. You're never staring at a totally blank screen wondering where to begin.
That's helpful.
Definitely. And from there, you can easily save whatever inputs you're currently working with to the data library or load up sets you've saved before. Plus, you always see the name of the data set you're currently using right there in the interface, top left corner.
Oh, that's handy. So you always know which scenario you're looking at.
Yeah.
Avoids confusion.
It's a small thing, but it makes a big difference for usability.
Okay, so once you're using it, how do you actually manage these data sets? Like opening a different one, or maybe setting up a whole new scenario, or just updating the one you have?
It's pretty intuitive, actually. There are clear options. You hit the open button, again, top left, and it brings up a list, basically. You can choose any existing input data set you've already saved in the library.
Okay.
And if you want to define a completely new one, maybe you're building an example scenario. You use that same open button function, but you define a new name, like example, and then save your current inputs under that name. And boom, example pops up in the corner as your active set.
And just saving changes to the current one.
Yep. There's a save button for that, too.
Yeah.
Just saves the current data right over the existing file with the same name. Keeps things streamlined for quick tweaks and comparisons.
Right. Makes sense. So that covers the kind of static input data. But energy systems are so dynamic, aren't they? Always changing. That brings us to the distribution library. This sounds like where the model handles that fluctuation over time, like hour by hour.
Exactly. This is where it gets really interesting for time series stuff. Things like energy demands or how much power you get from renewables. They're usually defined with an annual total value, right? But the hourly variation across the whole year, that comes from a specific distribution file named in this library.
And how are these distributions actually stored?
Well, this might surprise you. They're just simple text files, plain text. Each file contains exactly 807.84 hourly values, one number per line.
8784.
Yeah.
That's every hour in a year, including a leap year day.
Precisely. It ensures you've got that full year covered for really detailed modeling. And because it's just a text file, it's super lightweight, easy to share, pass data between different users or projects.
A simple text file doing all that heavy lifting. That's quite elegant. So these 8784 numbers, do they always mean the same thing? Are they always like actual energy values?
Good question. No, the interpretation depends on what the distribution represents. So for something like electricity prices, yes, those 8784 numbers are absolute values. The price for each hour, fixed. But for demands, electricity demand, heating demand, all the values in the file are relative, like percentages of the annual total. So if you set your annual electricity demand to, say, 100 TWH, and the distribution file for a particular hour has a value of, let's say, 0.00001, the model calculates the demand for that specific hour based on that fraction of the annual total.
Ah, I see. So you can change the total annual demand easily without messing with the hourly pattern.
Exactly. You just change that one annual number. Super flexible for scaling things up or down. And it's the same idea for renewables, like wind or solar. The distribution is relative to the installed capacity you specify. The key thing is that the name of the distribution file being used is part of your main input data set. And it's really easy for a user to just swap them out. Choose a different wind year distribution, for instance.
Okay, so if I'm a user and I want to use my own time series data, maybe for a specific region, or maybe I have newer data, how do I change a distribution or even add a completely new one?
Changing one is simple. Next to the parameter, like, say, electricity demand, there's usually a button. You click it, and it opens up a list, a tab sheet, showing all the available distributions in the library. You just pick the one you want.
And defining a brand new one.
That means creating your own text file with those 8784 numbers, and the model is very strict here. It has to be exactly 80784 values. All numbers, one per line.
What happens if it's not right?
You'll get an error. Common mistakes are maybe using an 8760-hour file, which is standard for a non-leap year in some other contexts, or maybe having too many values, or sometimes there might be text, like units or notes, accidentally saved inside the data lines instead of just numbers. The model will flag that. Consistency is key.
Any tips for creating these files? 878 and 84 numbers sounds like a lot to type out.
Oh, definitely don't type them. A really quick way is to just copy an existing distribution file from the library. Open it up, maybe load it into something like Excel, make your changes to the numbers, and then save it as a new text file with a new name.
That makes sense. Leverage the existing structure.
Exactly. And another useful tip, you can add lines at the very beginning of the file that start with a /. The model ignores these lines for calculations, so you can use them to put in notes about the data source or the year or whatever. Great for documentation.
That's a good feature for keeping track of things.
Yeah.
And you mentioned the library already has data. It's not empty when you start.
No, not at all. It comes preloaded with quite a bit of useful data, gives you a solid starting point.
What kind of things are in there?
Well, there's typical Danish electricity demand from back in 2000, typical Danish district heating demand too, distributions for solar PV output, solar thermal, also the distribution pattern for industrial CHP, that's combined heat and power, very efficient.
Right.
It also includes several different wind years. I think 1996, 2000, 2001 are in there. That lets you test how different wind conditions affect the system. And even electricity market price distributions from the Nord Pool Exchange for 2000 through 2006.
Wow, quite a range.
Yeah, and the model even includes some helpful diagrams to visualize these. They show, the pattern over months and zoom in on a typical week in January for electricity, heating, wind, and solar thermal. Helps you get a feel for the data.
Okay, that gives us a good picture of the data and distributions. Let's switch gears slightly to the cost database. How does that fit into the overall picture? Is it just another part of the input data?
Yes and no. It specifically holds costs and investment costs for technologies, fuel costs, but its real unique value is that you can swap out the entire set of cost data very quickly without touching any of the other inputs like demands or capacities.
So it's modular.
Exactly. Think about doing sensitivity analysis. You want to see what if fuel prices double or what if wind turbines get cheaper. With the cost library, you can just load a different cost data file, maybe one called high fuel prices, and rerun the analysis. You don't have to rebuild everything else.
That sounds incredibly useful for exploring different future possibilities. So is saving or loading this cost data different from managing the main input data sets we talked about earlier?
It is different, and that's a really important point. When you save or load the main input data, that includes everything demands, capacities, efficiencies, and the currently active costs. It's the whole snapshot.
Okay.
But if you specifically use the options to save or load cost data, that only affects the investment and fuel cost numbers. Everything else stays exactly as it was.
And where do you do that? Is it obvious in the interface?
Yeah, it's handled in a specific section, usually labeled something like the cost additional tab sheet. There are separate buttons there like save cost data or load new cost data. Clicking those brings up a selection window, similar to the one for main input data, but just for your saved cost scenarios. Gives you that precise control.
Got it. Very targeted control over a really key variable.
Okay.
One last piece then. The settings tab sheet. What does that let the user control? Is it just about how things look?
Well, it does handle some display things, yes. You can define the energy units you want to see. Choose between using kilowatts and gigawatt hours per year, or maybe megawatts and terawatt hours, or even bigger units like gigawatts and petawatt hours per year.
And money units, too.
And monetary units, yeah. Euros, dollars, kroner, whatever. But here's the key point about those display settings. Changing them only changes how the units are shown on the screen, on the different tabs, and on any printouts.
So it doesn't actually change the numbers themselves? If I switch from GWH to TWH, the underlying value doesn't get divided by 1,000 automatically?
Correct. It does not change any of the input or output numbers themselves. It's purely cosmetic for display purposes. You still have to make sure your input numbers match the units you intend to use, regardless of the display setting.
Okay, that's a crucial clarification. So settings are mainly about display units.
Primarily for units, yes, but depending on the model version or specific setup, the settings area might also hold other configuration options, maybe related to calculation details or specific constraints. But the main function described is usually units and currency display.
Okay, so we've really journeyed through the core structure of EnergyPLAN, the data library, the distribution library, the cost database, and the settings. It's pretty clear how having these separate but connected pieces allows for some really robust but also flexible energy modeling. You can swap things in and out, compare scenarios.
Absolutely. And if you think about the bigger picture here, really understanding these data structures, how inputs are validated, how things are kept modular, that's just so critical for having confidence in the results you get from any complex model, right? Whether it's energy or finance or climate science, it's about trusting the process, knowing how the analysis is built.
Yeah, it really drives home that point. By organizing the data this way, granular yet super organized the model lets you do these incredibly detailed year-long simulations. You can make very specific comparisons without getting totally lost in the complexity.
It definitely empowers a much deeper level of analysis, which, thinking about it, raises an important question, doesn't it?
Go on.
Well, how does knowing that the underlying data is carefully managed, validated, structured like this, how does that change how you perceive the information you get from complex tools or analyses in general?
That's a great point to leave people with. Think about it. This rigorous organization we see in EnergyPLAN. How might that apply to other complex stuff you deal with? Financial forecasts, maybe health statistics, climate projections. Does knowing that the data behind the scenes is meticulously curated and checked, does that change your level of trust in the information you consume every day? Something to definitely mull over.